In the last example that we did, we talked about direct variation. That's where y is directly related to x, and it goes straight across. What we're going to talk about now is inverse variation, where we still start off with y equals k, just like we did before. Before, remember, it was y equals kx. Always start off with y equals k. And the x, the position of that is determined by the type of variation that you have. So if it's direct variation, it goes straight across. If it's inverse variation, it goes down. So you would have k divided by x in this case. K is still called the constant of variation. And an example of this, or a description rather, would be when one variable goes up, the other goes down. Or vice versa. If one goes down, the other goes up. So an example would be this one. If it takes 2 people 2 hours to paint a room, how long would it take 5 people to paint a room? Well, hopefully if you have more people working to paint a room, it would take less time, right? So as the number of people goes up, the amount of time goes down. This is called inverse or indirect variation. Let's look at an example. Y varies inversely as x. We can immediately do y varies inversely as x. Then it says y is 6 when x is 3. Find y when x is 9. So we use what we know to find k. Y is 6 when x is 3. We are going to multiply both sides by 3. So that we end up with k is equal to 18. So if we want a generic formula, we have y equals 18 over x. We use our generic formula to find what we're looking for. Find y when x is 9. So y is equal to 18 divided by 9, which means y is 2. And look at this example. The water temperature of the Pacific Ocean varies inversely as the water's depth. At a depth of 1,000 meters, the water temperature is 4.4 degrees Celsius. What is the water temperature at a depth of 5,000 meters? Okay, so they didn't tell us any variables this time, so let's just choose some. It says the water temperature varies directly as the water's depth. I think I'll use T and D because temperature varies inversely as depth. That actually gives us our formula. Temperature varies inversely as depth. They also told us that at 1,000 meters, the temperature is 4.4 degrees Celsius. So we know the temperature, we know the depth. We have 4.4 is equal to k divided by 1,000. We solve for k by multiplying both sides by 1,000. This will reduce to 1, and we get k is equal to 1,000 times 4.4 will be 4,400. So our generic formula, I don't know if that's blurry or not. There we go. Our generic formula is T equals K divided by D. So temperature equals 4,400 divided by depth. Now we can use that formula to finish the problem. What is the water temperature at a depth of 5,000 meters? That means D is 5,000. T is equal to 4,400 divided by 5,000. So we have 4,400 divided by 5,000, and we get 0.88. Now what does that mean? Well, this is temperature, and it's in degrees Celsius. So at 5,000 meters, the temperature is just above freezing at 0.88 degrees Celsius.